Hello, welcome to How to Navigate and Customize Aspen Plus V. My name is Jennifer Diamond, and I'm the Product Marketing Manager for Aspen Plus. We are very pleased to have David Tremblay here as a presenter today. David is the Product Director of Aspen Plus here at Aspen Technologies. He has over 25 years of experience in various roles related to the development and use of Aspen Tech products. We are very pleased to have him presenting. Aspen Plus is a part of a whole suite of integrated products called Aspen One Engineering. Large and small companies alike have access to the software using tokens or the engineering desktop. Over the last 2 years and going into the future, we have been hosting webinars showing the many features available with Aspen One Engineering. Here is the agenda for today. I would like to take a minute to discuss some of the recent webinars that we've had on Aspen One V8. Then Dave will go into what is Aspen Plus V and who is using it, the innovations that have transformed engineering with Aspen Plus V, and the new Aspen Plus user experience. So this series of webinars on moving to V had two other webinars, one on Aspen HYSYS, which was in January, and then another on converting your Aspen Plus or Aspen HYSYS models into V8 from V7.3, and that was in February. We've also had many webinars on safety analysis, both for Aspen HYSYS and Aspen Plus. Here are just two. We recently also had a webinar Dave presented as well in September on Aspen Polymer. We have had many webinars on solid welding. These are just three. I think we've had about 6 on various topics, including just introduction and going more into detail with drying and fluidized bed reactors. We've also had a few webinars on activated economics, and 2 are listed here. We've also had webinars on energy analysis, heat exchanger design and rating, and installation and inversion comparison. As was mentioned earlier, these slides will be sent out, and you'll have access to these links to view these webinars. So with that, I'm going to hand it over to Dave. I would just like to mention that if at any point you would like to submit a question, please feel free to do so. Just be sure to submit your question to all panelists, and we'll address those questions at the end of the presentation.
Okay, thanks, Jen. Hello, everybody. Let's take a step back and look at the evolution of process simulation. When I got into this business in the 80s, we were just switching over from mainframe computers like the VAX VMS or the Unix workstations to personal computers. And that was the start of the desktop revolution. We developed the first visual user interface Aspen Plus, first on X Windows actually, and then porting over to the desktop. And the look and feel of Aspen didn't change very much through the 1990s and into the first decade of this century. We had similar desktop tools for energy, for equipment design, for cost estimation, for basic engineering. And all of these have some things in common. They're based on the old Windows metaphors of pull-down menus and toolbars. In the beginning, it was very simple. There's a limited number of features and commands and things that you can do in Aspen. But over time, as the software evolved and we added new features and added capabilities, it became somewhat muddled with many different capabilities, lots of things under the pull-downs, and more or less in confusing order in some cases. So a lot of good capabilities were hidden under multiple levels of menus. For example, to do a property, to make a binary analysis curve, you would have found that was buried 4 levels deep under a pull-down menu. As a result, there's lots of hidden capabilities that the average user never found or used. Today, we've brought out a new generation of Aspen Plus, the version 8 series, which is based on the ribbon paradigm, similar to the newer versions of Microsoft Office. We've also divided the software up into different environments to to be more workflow focused. So for example, we have a physical property environment that has all of the commands for estimating and evaluating physical property. We have a simulation environment for building and running models. And more recently, we introduced a energy analysis environment for evaluating the energy efficiency of your process, and a safety analysis environment for sizing and rating pressure relief devices such as relief valves and bursting discs. We've also done this in what's called the new shell. A number of AspenTech products use this new framework, including the new Aspen Plus, the new HYSYS, flare analyzer, chemical supply chain, and some of our other products. This new shell has a lot of nice capabilities. You can place your forms across your work surface, which I'll show in the demonstration. You can even put forms on a second monitor, so you can customize your workspace. We've made it much easier to make plots and to do some of the things that you do very frequently. And with the introduction of something called activation, we've made it easy to analyze the cost and the energy efficiency of your process, and to use our rigorous exchanger design tools to size and rate the heat exchangers in your process. These days, about 90% of our customer base has at least some users using the new Aspen and the new HYSYS. About 56% of users are using new Aspen Plus in January, and we know our average usage is just crossing the 50% mark towards the end of the year last year. So a lot of users have already made the transition, and with the end of support for 7.3 coming this summer, we're recommending the rest of the customers to also make this transition. So let's talk a little bit about the technical features in the new version. Over the past 24 months, AspenTech has invested a considerable amount of money in our products. We've brought out new interfaces for Aspen Plus and HYSYS. We've better integrated our pinch analysis software and our economic evaluation software so that you can get energy efficiency estimates and recommendations for improvements directly inside the simulator. And you can also get cost estimates within the simulator. More recently, we've improved the workflow for sizing and rating exchangers and converting from shortcut exchanger models to rigorous exchanger models. With the acquisition of SolidSim GmbH a few years ago, we've introduced a whole family of new unit operation models for solids and much more rigor for modeling particulate processes. We also recently acquired and introduced relief sizing software into both Aspen and HYSYS. We've made big investments into Aspen properties to make it faster and more efficient. And we've introduced a host of other capabilities to better leverage information, sample models, and applications through tools like Aspen One Exchange that make it easy to find getting started guides, learning materials, and other content for Aspen. So let's talk a little bit about activated analysis. With activation, with a few clicks of the mouse, you can quickly evaluate the energy efficiency of your process. But this goes beyond just rating the process. You can also use the pinch analysis optimizer under the hood to quickly come up with options for improving energy efficiency. And I'll show you that in more detail in the demo. With the economics activation, I can quickly evaluate the operating costs and the capital cost of my process. And then I can compare the cost of one scenario against another as I, for example, compared different distillation trains for separation in a new process. And with exchanger activation, I can design and rate different types of exchangers, including shell and tube exchangers, air-cooled exchangers, and plate exchangers, using our proven and rigorous exchanger models inside Aspen Plus. This makes it much easier to screen more alternatives more quickly during conceptual design and to help bring the feed process forward to do more of that activity during the early conceptual design. It also helps process engineers collaborate with mechanical engineers who do the exchanger sizing and mechanical checks, as well as estimators that would take on the preliminary relative cost estimate and generate a higher fidelity, more detailed and thorough cost estimate. The activated energy analysis, in addition to evaluating the energy efficiency, can also estimate the carbon footprint of your process. And if you're in a region that pays a carbon tax, you can enter a carbon tax and generate the carbon penalty that you pay. This can help you reduce utility consumption and also benchmark your processes against each other and against competitors' processes. The economic analysis helps you do relative cost estimates. And those relative cost estimates can help guide better decisions during the design process. An activated exchanger analysis can help identify operating problems when you evaluate different cases. So, for example, if you have a new plant or a new design and you wanted to evaluate turn down, turn up, summer, winter, and so on, you can quickly see if under some of those conditions you might have vibration or excessive velocity or other operating problems in your exchangers. You can also find the lowest cost exchanger design using the cost optimization algorithm that's available through some of our exchanger modules. Solids modeling brings together rigorous new models for solids processing unit operations. For example, granulators, spray dryers, crystallizers, various solid liquid and solid vapor separators, and so on. The new models are state-of-the-art technology, and we've very much improved the visualization, the particle size distributions, moisture content, and other factors of interest when you're modeling particular processes. This allows companies to simulate the entire process, including both the fluid handling operations and solid handling operations, and optimize globally across the process. Today, many companies have solid particle scientists that focus only on individual unit operations. By modeling those operations inside a system simulator like Aspen Plus, you can improve the whole process. Now, we've introduced a wealth of online training, sample models, get started guides, and other materials to help process engineers get started modeling solid processes. So this certainly isn't limited to specialists like particle scientists. Any process engineer that's familiar with the basic principles of simulation can get value from these models. They're available at different levels of fidelity, from simple shortcut models through high-fidelity equipment-oriented models. So the philosophy of these new models is with a single unit operation, you can model various types of equipment. So we have about 20-something unit operation models in the library, but with those models, you can represent 70 different types of real equipment. And this allows you to track particle size distribution and moisture content of the solid particles throughout the process. More recently, we've added, in the newest release, 8.6, relief sizing and design. We've always had some rigorous pressure relief rating capability in Aspen. What's new is analysis for scenarios like fire and multi-valves, as well as the sizing of the relief valves. So it's not limited to just rating geometry that you specify. The new system will find the right valve sizes for the different scenarios and document that through data sheets and other engineering collateral. So with a new system, you can design and evaluate pressure safety systems involving both relief valves and other relief devices. You can use rigorous methods for scenarios such as fires, stuck valves, pump failures, and so on. And this is all based on API standards and other standards to ensure that the sizing is meeting industry standards. So again, this is in a separate environment where you have a static version of the flow sheet. And in this version, you can add valves to protect the various equipment. Once you've added the valves, you can use the scenarios built into the software to size those valves to find the required size under different conditions. And finally, create your regulatory reports and data sheets needed to document those valves. This includes the newest standards, such as the API 521 for relief valve calculations, API 520 for PSP sizing, and the API 2000 standards for low pressure vessels. Now, this new capability fills what was a gap in the workflow from coming up with the relief loads with a simulator and then downstream modeling the flare system. So the new pressure safety capability can read the conditions from the simulator, including the physical properties of the various streams, use that in the relief valve sizing, and then that information can be shared with the flare analysis tools, Aspen Flare Analyzer. So we do have some customers that are starting to use this, and there's very significant benefits in having the relief valve system directly tied to the simulator. You avoid having to move data from one tool to another, and you avoid the potential errors in data transcription. Now, with the new version of Aspen Plus, we've, of course, kept the physical properties up to date with the newest standards. We've made significant improvements in the speed of the PC-SAP model, for example. We've updated with the newest NIST and different databases. And we've made the analysis, like binary property analysis, pure component analysis, mixture analysis, much more streamlined. So with a few clicks, you can quickly get a phase diagram or a binary analysis for a system. With the most recent version, in line with our work in solids modeling, we've introduced new physical properties to calculate the precipitation points. These are analogous to the bubble points or the dew points, except this is the point where in a liquid solid system you get the first cloudiness or first incipient precipitation. We've also done work on our flash models to make them more reliable and robust, especially for difficult chemical systems like multi-phase systems with electrolytes and complex phase equilibrium. The new system through Aspen One Exchange includes a number of self-service e-learning content. So these are computer-based training modules and how-to videos that you have direct access to. They're organized by topic with cross-links from one topic to another. So far, we've had over 17,000 users using this training material, and we've had very good feedback from it. So you can get to that content from the resources ribbon in both Aspen Plus and HYSYS under the e-learning button. Now I'll bring up Exchange with a wealth of content. when you click the little play button, it'll open up in a browser type window, and you can go through that content. Some of it is interactive, and some of it is static video that you can watch to learn how to use a new feature, or how some of the things have changed in the new versions. This helps both new engineers and people new to this version quickly learn how to use it and get up to speed. So let's take a look at the product. I'm going to share my desktop. Here you can see the new Aspen Plus. This is version 8.6, the most recent version that's shipping. You can see some things are still familiar, like the navigation pane on the left and the model palette and the flow sheet. But there's other areas that are changed. The most obvious one being, instead of toolbars and buttons, we have a ribbon. Now, the ribbon is set up for following different workflows. So, for example, we have in both environments, we have a home ribbon. So here we can see the most used functions, and generally laid out in the workflow from left to right. So one of the first things you might do is set up your units of measure. Then you can run your model, view some of the results, maybe set up sensitivity studies, and so on. There's other ribbons for particular workflows. So for example, we have a whole ribbon dedicated to evaluating the cost of the process. The first thing you might do here is set up the cost of your feed streams and product streams. Maybe set the cost of each of your utilities. So if I just go into one of these utilities, you can see here you can enter the cost of the utility, what type of utility it is, the state conditions. And one of the things we added back in 7.2 or 7.3 was the ability to track carbon. So by picking rules for either the US EPA or the EU standards and specifying the fuel that services your plant, we can track the carbon equivalents associated with heating and cooling utilities. And then there's some other cost options I might want to set up. For example, selecting the right costing template that my estimator provides me. So if this plant is built in the US, I would use a US template. If it's a new plant in the Middle East, we have a Middle East cost basis that would be more appropriate. We have other tabs here for doing things like setting up a model for dynamic simulation. We have a whole ribbon tab dedicated to equation-oriented modeling. So some of you that are very familiar with Aspen EO, we've brought onto the visual interface for the first time a lot of features that were formerly available only through a DOS window, like getting the solver reports or the bounds reports. By bringing together the entire EO workflow in one place, we've made it easier for the EO expert. We've also made it easier for a new engineer to learn how to use EO. Now, you may notice on the left side, we have a number of different environments. This is similar to Outlook Mail, where you have your mail, your calendar, your to-do list, and so on. In the simulators, the main environments have to do with setting up the physical properties and the chemistry, setting up the simulation, and then some additional analysis like the safety valve analysis and energy analysis. I'll just pop over to properties real quickly. In the properties environment, I have all of the features that have to do with fitting physical properties, estimating properties, finding data from sources like NIST, and so on. Now you can see one of the things we've made much easier in this version is to do quick property analysis. So let's say I wanted to do property analysis. I would go into analysis mode, and then I can choose whether I'm doing binary, mixture analysis, maybe ternary diagrams, and so on. So in this case, I'll do a quick binary analysis. Let's take a look at the equilibrium between acetone and phenol. Click the run button, and in a couple seconds I can get my phase diagram and maybe think about how the best way to do a distillation of the system is. Here I can see I have an azeotrope, so I know I'm going to have some trouble. If I go back into my simulation environment, just going to quickly run my model. So this particular process is the production of bisphenol A that's generated by reacting phenol and acetone in a packed bed reactor, which we're representing as a rad frac for the reactions in this model. And then we go through a series of steps where the product, bisphenol A, is separated from undesirable isomers through crystallization. So we go through a crystallizer, and then those crystals are separated using a centrifuge. And then it's redissolved in another solvent. So this happens in 2 or 3 stages to come up with a very pure bisphenol A as a liquid product in the end. Now, the new solids capabilities in Aspen make that possible for the first time because we have very good, rigorous models for units like the centrifuge, as well as the dryer. And so let's take a look at how we might use some of the features in the new UI to model this process. So one of the things I like about this new version is I can save my different layouts. So earlier, I set up some windows, and I'm just going to bring that back up. So if I go to my View menu, under Switch Layout, I'm going to call up the layout I saved before. So it's dryer study. I'm going to zoom over here to the dryer. So one of the things you can see here is with the new interface, I can lay forms side by side, including the flowsheet form. And I'm also showing on the right one of the new features, which is something called custom table. With the custom table, I can bring together inputs and results from all different parts of my model into a single grid. This is similar to what you might have done with tools like Simulation Workbook in the past, except that was inside Excel. Here I can do it directly inside Aspen Plus. And it's really easy. It's just drag and drop. So let's say I wanted to see, maybe I want to see the solvent in my outlet stream. So let's go to my outlet stream, and I'll go to, let's see, the toluene level. I can do coffee, and I can come over here and just do paste, and it adds it to the table. And I can rename it. Okay, so you can see how easy it is to build this table. Now from this table, I can do various things. One of them is I can do case studies. So earlier I put in the drum speed for the centrifuge. Now if I spin my centrifuge more quickly, I should be able to remove more of the moisture and unload the duty of the dryer. So I've actually got an optimizer wrapped around this dryer to minimize the airflow to meet my moisture content specification on the outlet of the dryer. So I can see right now the various costs of my different heating and cooling utilities around that dryer is about $190 an hour. So if I change my drum speed a little bit and rerun the model, when the model's done, I'll see my new cost. Okay, so now I've brought that cost down to $185 an hour. Now you can imagine if I was to hand this model off to a colleague, by putting all the key inputs and results in one place, it makes it a lot easier for my colleague to understand how to run case studies in the model. They don't have to know how I built my model. They don't have to know all the details of what assumptions I made and so on, as long as my model's been designed to be robust enough to run under different conditions. Now I can put this table directly on my flow sheet if I want. Just click this button, and now it puts it on the flow sheet, and I can drag it around to where I want it to go. And I can have as many of these tables as I want. So I could have liberally sprinkled these all over my model. Okay, now it can be there as an icon, or it can actually show up as an actual table. Okay, and I can enter the data directly here on the table if I wanted to. Another nice feature is we've made it more flexible for showing whatever you need to show on the user interface. So So, for example, right now I'm showing temperatures. If I wanted to see pressures, I can just click on the pressure button here on the flowsheet modify ribbon. Now, like any ribbon, we have some additional capabilities that are launched from these dialog launchers. So down here next to screen results, I click there. Here I get a menu of all the things I can show on the flowsheet. And in the new Aspen Plus, in addition to the built-in properties like temperature, pressure, and mole flow, I can put in any property set. So in my case, I may be interested in, say, the dew point. So I'll just go here to a new custom one. I'll call it dew point. And I'll create a new property set. So maybe I also want to see the moisture content in my solids. I set that up a little earlier, so I'll add that as well. Okay. With just a few clicks, I can quickly see my dew points. So here on the outlet of the dryer, I'm just under a degree C in dew point. And I can also see my moisture content, or my solid purity in this case. You can imagine how this can make a flowsheet much easier to understand. Maybe if I was looking at an electrolyte flowsheet, I would have put pH there. If it was polymers, I would put on maybe the intrinsic viscosity or the number average molecular weight. So this can make the model really talk the language of the process and make it easier to understand. Let's take a look at the dryer itself. This is one of our new unit operation models. So you can see within the dryer, although it's a single dryer block, I have a number of options here. So I can model it as a shortcut where I more or less specify the outlet moisture content. Here I'm using a convective dryer model. This is a rigorous model. If I decided that my process calls for a spray dryer or a contact dryer, I have options to model those types of equipment as well. Now, since I'm in the dryer model, up here on my ribbon, I get all the options for the different kinds of results I can plot for my dryer. Maybe I want to see the particle size distribution coming out of that dryer. So here's a PSD on a cumulative basis. I can also see it on a fraction basis. So you can see the shape of my particle size distribution curve. And there's other options that particle scientists might be more familiar with, like mass density distribution. I can also see things like the evaporation rates, the moisture contents, and so on. Or if I go to the results view, whenever I'm in a view that shows profiles, I also have the option of doing custom plotting. So here maybe I want to see the temperature of the vapor and the solids, and let's also look at the evaporation rate. So with a few clicks of the mouse, I can easily see what's happening in the dryer. So across the dryer, the solid temperature is getting pretty close to the vapor temperature. And I'm starting out with a sort of a constant rate drying until I get about here, about 1 meter through my dryer, and then it's going into the falling rate drying mode. Now, the custom table also makes it very easy to send this data to Excel. So it's a little bit off screen here if I just drag. With a single click of the button, I can send this thing to Excel. And I can do that as either a static report. So I just want to make an Excel sheet to document this for maybe for a report I'm writing. Or I can choose to make this a live simulation workbook. And if I do it as a live workbook, it's going to create all the links I need. And with just a few clicks of the mouse, I have a working ASW interface to this model. So just give it a name. It takes a minute to build that interface. Okay, and ask me if I want to turn it on. And I'll say, go ahead and attach to my running case. Okay, so now I've built a really simple simulation workbook with an exactly the same variables that I had in my my simulation model. And this is live. I could change this back to 300, rerun my model, and I'd see all the results update. Let's go back to the standard demonstration. Okay, so you've seen how I can use some of these new features. Let's take a look at one of the more powerful features, which is the activation. So I'm just going to turn on the activated analysis pane. And I have here a few big buttons, and these correspond to the energy analysis, economic analysis, and exchanger design. I'll start with economic analysis. So when I click this button, in the background, it's taking all of the data from my process simulation, and it's sending it to Aspen Process Economic Analyzer. Economic Analyzer will do rigorous cost modeling using the inputs and results from my model. So for example, if I've sized these columns, it will use those sizes directly. If I haven't sized my columns, the Economic Analyzer has a sizing algorithm built in that will fill in the gaps. Cost modeling also figures out things like the foundation required to support that column and the steel required to hold up the column, the instrumentation, the controls for the column, the labor to build that plant, the labor to operate the plant. So it factors all of that in to the operating and capital cost estimates. When it's done, it shows me the key results, the overall capital cost, and the total utilities for the cost. And that includes, by the way, electricity and some of the other utilities that I might not have considered rigorously in my simulation model. It also highlights the key contributors to that cost. So if I hover over my flow sheet, I can see the most expensive unit operations to operate. So unsurprisingly, it's 3 of my distillation columns. And I can change that to show instead the highest capital equipment. So these are the most expensive equipment to build or purchase. In this case, it happens to be my air compressor and 2 of my crystallizers. Now, there's a lot more depth here, so I can drill into the details. By going to capital cost, I can see more rigor into my cost model. I can see all of my utility costs for different levels of steam and the power that's running my plant. I can see a summary of all the individual unit operation costs. And this is also filterable, so maybe I want to bring the most expensive units to the top. Now, I also have a lot of control over how these calculations are done. So if I go into one of these tabs here, these are the various equipment that my model represents. So for example, here I have my centrifuge. You can see for the centrifuge, a lot of the inputs to those cost models actually came from the results of my simulation model. And I can also make changes here. So maybe I want to switch to a different type of steel. If I have a corrosive material, I may need a higher grade stainless. So maybe stainless 430 instead of carbon steel. I can also account for things like duplicate items. If I have a pump and a standby, I can set my design pressures and temperatures and so on. So this provides me a good baseline of my initial design. As I change that design, I can always go back and compare the cost against that baseline. Okay, so I'll close out the costing. And by the way, when I open the costing, that's when it's consuming the extra tokens for that feature. When I close it, it's releasing those tokens. So now I'll do a quick energy analysis. So I know what my plant costs, I know what the operating costs are. How energy efficient is my plant? So I'll use the energy analysis to figure that out. Behind the scenes, again, it's taking my simulation results, it's sending it to Aspen Energy Analyzer, which was formerly called HXNet. And that's using a rigorous heat pinch analysis to evaluate the energy efficiency, what's called the target heat demand, and of course, it knows the actual heat demands from my model itself. So it shows that on these thermometers. I can view it in terms of cost, or I can view it in terms of energy. At the top, I see my actual heat duty. This is the sum of all the heat duties across all the exchangers or boilers and so on. And the second value is the theoretical limit at the pinch condition. So I don't have to be a pinch expert to interpret this. I just have to be able to compare two numbers. Likewise for the cooling. And it also evaluates the greenhouse gas current emissions and what it could be at the pinch limit. And I can see that, of course, on a cost basis as well. So this is telling me my plant's about, from a cost point of view, about 60% as efficient as it could be. Now, we know we can never get to a perfect situation that would require infinite numbers of heat exchangers, but we can evaluate options. I'm going to quickly evaluate some options here by running this generate feature. In the background, it's using MINLP optimizer to evaluate several different scenarios. So can it modify one of the existing exchangers by adding tubes or adding area? Can it relocate an exchanger from one stream to another? Or can it find ways to add additional exchangers for process-to-process heat exchange to save operating costs? That will often, but not always, come at the expense of additional capital. So we do up to 5 evaluations. That's to give you some options to choose between. So this just takes a second or two. Okay, so now we can see that it found a scenario where I can add one new exchanger, reduce my energy cost by about 9.5%. That will pay back in about 0.13 years, whatever that comes to in months. And in this case, it will actually save me a little capital, probably by making other exchanges in my process smaller. Okay, and in the net, that's going to save me about $170,000 in operating costs. Now, if I wanted to learn more about that option, I can click here. It's going to take me into the energy environment, and I can see in a lot more detail what that option actually means. Okay, so if I go to my add options, here it's telling me if I add a new exchanger upstream of condenser of one column and the reboiler of another, that I can save 3.4 gigacals of heating and cooling. Okay, and it also provided me some other options, different ways to add new exchangers. So I go back to my process. In this particular case, it's telling me that I could use the reboiler stream of one column to provide energy for one of the other columns. Okay, so again, I didn't have to be a pinch expert. We put the expert into the software to help you out and to help you make better decisions. Now, I don't have any rigorous exchangers in this model. If I did, I could use the new exchanger activation to convert that to a rigorous shell and tube model, and then to size that and rate that and check for operability problems like vibration issues. Okay? So I hope that gives you a good feeling of all the new capabilities of the simulation. And I'm just going to go back to, thank you. Back to the presentation. Okay, so we talked about many of the new features. I'm just going to skip through some slides here. about ribbons. Now, one thing I couldn't show you through the demo, of course, is that the new user interface allows you to use multi-monitor workstations. So if you've got a workstation with two big monitors, as many of us do here at Aspen Tech, you can get full advantage of that by dragging forms from one side to the other. So in summary, you'll see that the new Aspen Plus offers a number of good technical advantages, including solid modeling, safety analysis, relief valve sizing, energy analysis, economic analysis through activation, improved properties, and many others, as well as many good usability features. It's much easier to learn how to use, especially for young people coming out of school that your company may have to train. It's got a number of resources for online training and other content to exchange. And there's a number of nice features like the custom tables, being able to show any property on the flow sheet and so on, that makes the model faster and easier to use. Now, I'd just like to use this opportunity to point out that we recently shipped some new patches for both 8.4 and the 8.6 release. This addresses all the serious defects that have been found since we've shipped these releases the first time. It also includes a specific improvement to make Aspen start up faster, especially if you operate with a licensed server far from where you sit. So if your licensed server is on one side of the continent and you're on the other, this will make it much faster for your Aspen Plus to kick off when you click it in the morning. We've also improved the memory handling and addressed some radix point issues. These are common decimal issues that might trip you up if you're in France or Germany. Okay. Also, just as a reminder, the 7.3 and older releases are going out of support at the end of May. Now, for those of you that are interested in having a more hands-on training experience, we do have a one-day training course focused on making the migration from 7.3 to version 8, and you can find those on the support website on the training center. We can also do on-site training for anyone that's interested in arranging that. Now, I hope you join the many other customers that are already using the new versions to continue to get the same kind of benefits that you've always received from Aspen Plus, such as increasing capacity, reducing capital costs, and reducing energy demand. Those of you that would like to learn more about our products, we have a major global conference coming up in May. It's going to be held in the Westin Waterfront Hotel in Boston. It's really an excellent opportunity to get together with colleagues, with Aspen Tech technical experts, to exchange best practices, to learn how to use new products and new features, and just to see what your colleagues are doing and how they use our tools to get benefit. So you can visit the Optimize 2015 site to learn more.
Okay, so at this point, we're going to get ready to do the Q&A. As you can see on your right, two polling questions popped up. One is to describe your role, and the second is to answer what projects you're using Aspen Plus for today. So please just answer those quickly, and then we'll go to the Q&A part. Okay, so the first question is, can you explain the differences between the estimation tools in Aspen Plus versus the economic evaluation software title?
Yeah, certainly. We have three different economic products. We have one called Aspen Process Economic Analyzer that's designed for process engineers to do early cost evaluation. We have one called Aspen Capital Cost Evaluator. That's used by estimators to do high-fidelity cost estimates for new plants or new sites. And we have In-Plant Cost Estimator to evaluate the cost of smaller projects. What you saw today is a link between Aspen Plus and the Aspen Process Economic Analyzer. So under the hood, it's using the same rigorous cost engine. It's And typically, people that use the economic analyzer import the data from Aspen Plus or HISIS. So this is doing that importing automatically for you as well. The basis of those cost calculations would typically be set up by an estimator in your organization using the capital cost estimator. They would export a template that then your process engineers can point to. And when you're done, this relative cost estimate that you saw from Aspen Plus can be exported as a file and opened into the capital cost evaluator. And yeah, that does require, by the way, license for that feature. Now, if you're on the new commercial model or if you have the engineering desktop, you already have that license. But it would draw some additional tokens. So just, in the interest of full disclosure.
So why is the Azeotrope search tool not present in the Properties tab, but only in the Simulation tab?
Some of these decisions about whether something involved should be in the property environment or in the sim environment were there's a little bit of arbitrariness to a few of them. In that particular case, usually the Azeotrope search is done in hand in hand with the people using the concept block, which is a conceptual distillation block to figure out how to split azeotropic systems. So we felt like it belonged in the sim environment because it was used together with the concept block, which is in the sim environment. Now, from the properties environment, you also have access to the ternary diagrams, which will also give you an azeotrope report. So there is a way to get to it from both environments.
Thank you. For revamp projects, can you do the economic analysis on select equipment rather than total flow sheet?
In the current version, you can select which units are evaluated. We're making it a lot easier in next release to do subsets. So, for example, to block in or select multiple blocks on the screen and just do a quick estimate for them.
Is it possible to include the economic, energy, and safety analysis results in the optimization blocks?
Currently, the cost results, they're available for simulation workbook. So you could see them from some studies from workbook. It's not hooked up yet to work with the sequencer and the Aspen Plus engine. So you cannot do a sensitivity study or design spec or that type of thing for cost. That is certainly a direction that we're interested in moving in the future. So there's some questions about whether we're making any improvements into the underlying algorithms. I mentioned in my slides we have a full-time engineer that works on the flash algorithm. For example, we've made a number of improvements in both the Gibbs flash and the standard flash, especially looking at difficult systems that customers report. So, for example, 2 liquid phases with electrolytes. We've done a lot of work recently around predicting the incipient solid precipitation. That's to support crystallization efforts. We have a university project to improve our SQP optimization to make it more robust when rigorous derivatives are not available from the code. So this is an area we continue to invest in. Bear in mind, the simulators have been around 30 years and the easy problems are already solved. So, it's getting more and more difficult to make further improvements in convergence algorithms, not that we stop trying though. So there's a question about rate-based simulation, and if I did a rate-based model of a column, would that be used in the cost estimate? So basically with the cost estimate, if you have the sizing turned on in Aspen Plus, so if I have tray sizing or tray rating on in Aspen Plus, it will use those results in economics. To do a rate-based estimate of a column, I must give the tray geometry or the packing geometry. So when I do that, it will definitely inherit those results from the simulator and use that to evaluate cost.
Okay, what features have been added to V8.6 from V8.4?
So specifically for V8.6, I mentioned the property model, the T-sol and P-sol. Actually, you know, it might be interesting just to show you how to find that out yourself. So I'm going to share my screen again. Yeah, this is something I usually show in the demo, so I think it's worth showing here. New Aspen and New HIFIS have a resources tab. And one of the things that tab has on it is the What's New. So if I click on the What's New button, it'll open the help, and it'll show me not just what's new in 8.6, but it'll also show me all of the subsequent releases going back more than a decade. So you can see here for 8.6, some of the specific improvements include, of course, the release valve sizing that was added in 8.6. For solids modeling, we have the new contact dryer. We made a number of improvements for being able to specify the particle size distribution for any class of reactor. And we made some engineering improvements. For example, I can click on a heat exchanger, a heater, and convert it to a heat exchanger, or make a mixer or heater. We've added new results for heat exchangers to see the temperature curves, so I can visually plot a temperature cross. We made some plotting improvements and so on. Okay, a number of new physical properties, new components in the database. And I can walk backwards in time and see what was new in previous releases as well. Another one of the key features in 8.6 is the e-learning. So if I go under e-learning, you can see here it's got a number of categories. Maybe I want to learn more about solids modeling, so I can click there. And that's going to open Aspen One Exchange, and it'll show me all the content available related to my search. Okay. You might notice we also added a search bar to the top of the Aspen Plus ribbon. So I could have just typed in solids here, would have done a similar search and dropped me into Exchange. So much like you would do a Google search. From here, I can get into the content like the computer-based training for solids modeling. When I click play, it would then go on to open the computer-based training. Okay. Next question. So there's a question about the cost estimation, whether it's scale sensitive. Again, this system is using rigorous volumetric-based cost estimating. So it is certainly going to consider the scale of the process. And there are situations where if I have a very large-scale process, it will automatically decide that I need two parallel units instead of a single unit. It won't try to design a column or an exchanger that's bigger than you could physically make in reality or buy in reality. So it is cognizant of those types of issues. There's a question about catalyst deactivation and the kinetics. Generally, with something like deactivation, these are long-term, time-dependent phenomenon. So typically in a model, you would fit that, just like you would fit, say, fouling in an exchanger, based on current plant conditions. So, if you are using a kinetics algorithm that considers a solid catalyst, you can tweak that through either the catalyst mass or through an activity factor. There's a question about whether we have training videos for the petrofrac model. That we don't have a particular one around petrofrac. Generally, we've focused more on the petroleum side with Aspen HIFIS. We do have a number of videos on various content, including basic features of Aspen Plus, things like making plots. We have a whole set around solids models. We have another set around dynamic modeling. There's a CBT on custom modeler. And there's any number of videos on particular features, specific unit operations and so on, but we just don't happen to have one on petrofrac.
Okay, so that looks like all the questions that we have for today. If you have any additional questions, our emails will be in the PowerPoint that will be sent out. So please feel free to email either David or myself with any questions. Thank you for attending and taking time out of your day to attend the webinar today. Thank you very much and have a nice day.